Welcome along to topic 1 of managing a web server, and please feel free to ask any questions as we go and we'll try and do it. So the first topic, we're going to talk about web server concepts, and those web server concepts are concepts surrounding web servers. So the contents today, I've got this picture here, the crags that I made black and white just to make it seem more interesting. Added a bit of texture to it as well. I don't own the copyright to this image at all, so apologies to whoever took it. So what is a web server, first of all? What is PHP? What is a software selection? And then some questions, and then we'll go and look at how to set this up. So first of all, what is a web server? Right, so the primary function of a web server is to store, process and deliver web pages to clients. So as I said last week, you probably already used a web server today. We're using web servers right now to do this Teams call. I've got Teams open in a browser. This presentation is running in Google Slides in a web server. Okay, so on your phone, when you refresh the page or look at the news, you're looking at a web server, and those are HTTP pages that are being delivered by the server to your phone or your computer, which is the client. It's a client-server relationship. So we use this protocol called HTTP, and you can kind of think of it as a layer 7 OSI protocol. Pages delivered most frequently are HTML documents, but also images, PNGs, style sheets, little scripts to move things around, text are delivered directly to the device over the internet using this HTTP protocol. So in order to have HTTP working, we need to have the other layers below working as well. Like we'll need to have a port, transport layer port, we'll need to have an IP address, we'll need to have a connection to the server through the internet, we'll need to have layer 2 switching working, so we can get the frames from the router over to our local device or through the wireless access point to our device, and we'll also need to have layer 1 working if we're using Ethernet, okay, or some kind of hardware encoding. So we need all the layers all those layers need to be in place before we can get to layer 7. So HTTP, we have HTTP requests by our client devices and an HTTP response from the web server. Okay, so the World Wide Web, WWW, is about communication between web clients and web servers. They used to call it the information superhighway back in the 90s. That name never really stuck. Communication between client computers and web servers is done by sending requests and receiving responses. So if you open your phone and open up a search engine, DuckDuckGo, you type something in, you're sending a request to a server which will then send you back a web page, a response. So the client sends the request, the web server receives the request, the server runs an application to process the request, and it responds to the client device. And if you think about it, it's actually very clever, because that server can be in a data center somewhere, probably in Ireland for the lower corporation tax, and we can then get that information back from that server in almost instantaneously. Very, very clever how it actually works, so quick. It's amazing how many routers and things it has to go through as well to get to your phone. Really is unbelievable. That's why networking for me is such an interesting subject, because it's so amazing that it actually all works. Right, so HTML is the markup language for web pages, and it describes the structure of web pages, and it's open source technology. So you can right click on pages and say view source. The internet by nature is open source. And HTML tags label pieces of content, and browsers don't display those tags, they just display what's between the tags. And the definitive resource on that is this W3 Schools page, where you can learn all sorts of HTML, PHP, all sorts of web programming. So there's an example of, this is the Guardian's web page, and if you view the source on the Guardian's web page, they've put in text here, "We are hiring." So they're obviously looking for I don't know if they're still doing that, but this, when I got this, it says, "We are hiring, thinking about joining us." So if you're a web developer and you're poking around looking at the Guardian's source code, they want you to see this message. No one else can see that message, only people who are looking at the source code of the page. And here's a very, very basic example of what I would say just like a boilerplate page that would display in a browser. So HTML was all fine. I've got a book somewhere, it's actually in the back of my car, HTML2, HTML2. And what happened with HTML was, we ended up having lots and lots and lots of tags. So for example, if you wanted to change the colour of this font, you would have had a font tag, and then you would have to say what colour it was, and then you would have to say lots and lots of things about it, this size, this font family, this much padding, this much spacing. And the page just ended up looking like a giant mess. It ended up looking awful. So they invented this other language called CSS. CSS allows you to create styles, and then you can just refer to those styles within the page. So you could actually just put a style up here saying, you know, heading style, and you could say is red, is size 18, is this font, is this much spacing, and then in here you could just say h1 style equals heading. Okay, so you don't have to keep defining it again and again, you just define it once, use it anywhere. So HTML was not intended to contain tags for formatting a web page, it was for describing. So there was this old tag called color that's not used anymore, and font that's not used anymore. They'll still work, the browser will still interpret them, because the browser has to be backwards compatible for old pages, but don't really use them anymore. So here's an example of CSS. So I've defined a style up here, body, background color light blue, and then what we can do is in the head of the page we can link to the style sheet, and then we can refer to those styles as and when we need them. Okay. We can just create a style inline, or we can define the style inside a style tag, or we can put the styles in a separate file, which is usually called styles.css, but not always. Okay, so PHP and JavaScript then. So we had HTML, CSS, PHP is the pre-hypertext processor. And the key distinction between PHP and JavaScript is PHP gets interpreted before the page loads by the server, okay, and the result gets delivered to you. JavaScript, on the other hand, gets interpreted by the client, by the browser, and it gets interpreted after the page loads, or at the end of the page loading. So PHP is also open source, and we can use PHP to do server-side scripting, okay, on the server side. And the latest version of PHP is version 7. And some very famous websites are written in PHP. Wikipedia is one, it's written in PHP, and Facebook is written in PHP as well. A lot of PHP, and those are two quite big websites, as you can imagine. Right, JavaScript though is interpreted by your phone or by your browser. Okay, so when you load up something like Microsoft Office 365 in the web browser, they couldn't process that all on the server and send it to you, because it's not a one-time thing. So what happens is, when you open Office 365, you download a load of JavaScript from Microsoft, and that's how all the buttons and everything work. It's actually being processed by your computer. Someone said, I don't know how true this is, that when you open one of these Office applications like Google Docs or Microsoft Office, apparently it can download 500 meg of JavaScript onto your computer before it starts working. So I'm not entirely sure how true that is. I don't know how I would figure that out. Who knows? So in summary, we have HTML that defines the content of pages. We have CSS that we can use to specify styles, layout. PHP for server-side scripting. JavaScript to program the behavior of web pages. JavaScript's the programming language of the web browser, so the client side. And finally, HTTP is the protocol that we send these documents back and forward over the internet. And we have things called GET requests, responses, We also have errors. For example, when you see like a 200 error, when you see a 200, that's a success. When you see a 404 or a 400, anything that starts with 4, that's an error, an HTML error code, HTTP error code. Getting mixed up with my HTTP and my HTML. So, software for this class that we're going to use. We're going to use Debian in this class to set up our web servers. And the reason that we're going to use Debian is because many other distributions are based on Debian. So, for example, Ubuntu is based on Debian, Kali is based on Debian, Raspbian, which is now called Raspberry Pi OS, is based on Debian, MX Linux is based on Debian, Mint is based on Debian, Tails is based on Debian, which is like a privacy based. Mint is very popular with people who are just beginners because everything just works on Mint. It's probably easier to use than Ubuntu. There's also a Knoppix, which is like a USB pen distribution that if you had a broken system you could use it to recover. So my kind of reckoning on it was, well, why use any of the derivatives when we can just use the thing that it's all based on? If it's all based on Debian, why don't we just use the thing that it's all based on rather than using some derivative, these are called, because they're called derivatives because they derive from Debian. So there's a page here that says why Debian, and there's a big list of stuff. It's free software, it's 100% free, it'll always be 100% free. It's stable and secure. It has hardware support. For example, if you were to take an old printer out of a cupboard and plug it in, it would just pop up and say, "Ooh, looks like you plugged in an Epson 3452. Would you like to print a test page?" Because the drivers are already in the Linux kernel. Debian can use other kernels, but generally we use it with the Linux kernel. Pure OS is based on... it's good for developers. It supports multiple different types of hardware. If we look at the hardware list, we can support all of these different processor types, Power PCs, old Macs, ARM processors, MIPS processors, RISC 64 stuff, old server processors are all supported by Debian. And let's go back to here. So that's some of the reasons. It has many experts, so there are package maintainers. Now, the difference between Debian and something like Red Hat or Microsoft Windows is that Debian is a community-based distribution. So it's developed by a community. They have votes on things, and they have arguments and fallouts and stuff like that. But they discuss things openly about what they're going to do, compared to a distribution that's an enterprise distribution, like Microsoft Windows Server, where they decide behind closed doors what they think the best features are, thereafter incorporating them into the operating system because they've decided on. I think with Microsoft, if you had enough money, you could pay them to do something. They would add it for you if you paid them. But with Debian, it's done by discussion. So there's a blog here that'll tell you all the stuff. Debian is 29 years old. So the first distribution was released in 1994 or 1995, I think. Maybe earlier, maybe 92. Sadly, the guy who invented Debian is no longer with us as of a couple of years ago. I can't quite remember his name. Let me just search. Debian, I'll show you this guy. It's quite... Ian Murdoch, his name was. So basically, Ian Murdoch's wife was called Deborah. So when you join the word Deborah and Ian together, you get Deb Ian. So that's why it's called Debian. It's basically based on his name. If we go and look for Ian, yeah, so Ian Murdoch founded it on August the 16th, 1993, through an announcement, and it's been developed in the same way since, with a community. So it started as a small, tightly knit group of hackers and gradually grew to become a well organised community of people. Now, Ian Murdoch also invented something else that I'm going to tell you. There he is there. He also invented he was working for He was vice president of Salesforce, Docker. He was working for Docker when he died in 2015. But this was the guy who started it. So it's based on his he was a founder of the Debian project and Progeny Linux Systems, a commercial Linux company. So basically he is the Ian in Debian. That's why it's called Debian. Right, okay, so if we're going to install Debian today in VMware, what we need to do is, and I'll put this in the chat, is go to the following URL. So, well, I'll make it even easier so you don't even have to put the URL. So if we go to debian.org and then just go to download, and then we go to a page called Getting Debian, we can download a small installation image. So I'll fire this link in the chat just now. Where are we? Here we go. There. Debian.org/distrib. And what we want to do is download this small installation image. And it'll take us to this page. Now look, I was telling you Debian's supported by different CPU architectures. These are all the different architectures here. So if you click on AMD 64, that'll get us the 64-bit image, and it's 370 meg. So I'm just going to hit save file and click OK, and then look at that, 7 seconds that downloaded, a few seconds. And so the version that we're using today is called Debian 11.4. Okay, now you might think, what do all those numbers mean, and what's the significance of Debian versions? So I'll just tell you now. Debian has 3 versions running at the same time concurrently. There's the stable version, which is what we're downloading. There's the unstable version, which is the next version of Debian, Debian 12, and there is the old stable, which is Buster. Okay, and I think there's something beyond unstable called testing, which is just everything's broken and they're just testing stuff out. So each version has a code name which is named after a character from Toy Story. So what we are using just now is Debian 11 Bullseye, which is stable, and the current unstable, or the future distribution that's being developed at the moment, is Bookworm. Okay, and that's the next release candidate, and it's expected to have link time optimization enabled apparently. So if we go to the release table, you'll see here's where we are here, and that was released August last year, and Bookworm is expected to be released next year, probably about every couple of years a new version comes out. And then Trixie is going to be Debian 13, but that's not in development yet. And there's also this version called, and it's SID is always the unstable rolling release. Okay, so we have old versions are red, older versions but still maintained are in yellow here, latest versions in green, and future releases, so Bookworm will be out next year. Now, an interesting page that I found earlier, let me just see if I can still find it. Let's see if we move this over here. Let's see. I definitely found a good page about. So I was looking for information just about how long people have had Debian installed, and I found that some people have got this. Let's see, how long has Debian? How long have you had Debian running? Found a good post about how long have you been using Debian. So basically, I managed to find a post on the Debian forum earlier that some people have had Debian running since the 90s. So they've had the same installation running, they've just updated it since the early 90s. It's just exactly the same. They installed it. I'll try and find this page. Longest Debian installation. Let's see. Debian, how long does it take? Let's remind. Can't quite find it now, but I definitely had a page open earlier where we had people that were, they said, oh yeah, I've had Debian installed since 1998. I've upgraded the motherboard, the hard drive, everything, but they've kept the same installation running and just kept updating it to the new version, and it's been running for, 20 years or something ridiculous like that. Let me see if here we go. How many years have you run Debian without reinstalling? So this guy installed in 1999. Okay, it's been upgraded many times over the years. The OS has survived the motherboard upgrade, many hard drive changes, major kernel upgrades. He built a new system in 2008 and the old system couldn't be migrated. So that Debian system lasted from 1999 until 2008. About 8 years of 24/7 operation. This guy says, my home server was built and survived, keeps going. So this guy's had it running since 2007. This guy's had it running since 2004. Okay, and these people are running these computers 24/7. So that's like 18 years that's been running for. What else have we got? Here's someone showing the output from their command line. So this guy installed this on 2007. He's had it running since on this machine since 2007. So that's a long time ago. How many years? This guy since 2008. That's a very impressive story. The rest of you are wannabes. This person since 2009 want to fight about it. This person, for this wannabe, so this person's had Debian running since the 4th of September 2007. That's quite a long time to keep an operating system running for. Okay, so why are we going to use Apache in this class? Okay, we're going to use Apache in this class because Apache is one of the most popular web servers in the world. Now, it has just recently become about even with Nginx, which is another very popular web server. But in terms of your studies and your course, the next course that you'll do has some content on Apache. So until they update that, I'm going to stick with Apache on this course. Okay, so what I'm going to do now is just grab a file manager and just go to my downloads folder, and I'm just going to move this over to my virtual machines folder. So here's my virtual machines folder here. Just going to make a new folder, and we're going to call this Debian 11.4. Okay, and then in there I'm just going to paste that AMD net install ISO that I downloaded. Now, if you missed getting that, let me just grab the Debian, installing Debian by this. So you want the AMD 64 version. So what I'll do is I'll just copy that link and put it into the chat. Let's go back to the chat. There you go. There's the exact, if you click on that, that'll download the exact ISO that you want. Okay, so I'm just going to go through the setup on VMware now. Just tidy up some of these windows. Can we close those? We'll close this one, but I want to keep Jupyter running in the background, so let me just get that out of the way. And we'll tidy up some of these windows as well. Minimize that just now. Does Firefox not let you minimize? No minimize option. They give up on that, did they? Interesting. That's odd. Okay, we'll just throw it out the way then, will we? Let's get VMware open. Right, so here's my VMware workstation. I believe I'm using VMware 16.2, but it doesn't really matter. You can have VMware 12 if you like, it's not important. So let's go File, New Virtual Machine, and we'll go for a custom installation. This doesn't really matter. And we're going to browse to the Debian folder and choose that 11.4 AMD net install.iso. Clicking next, Linux, and it sees it's recognized already that it's Debian 11. And I don't want it to go into the folder that it thinks it wants to go into. I'm going to put it in the folder I made rather than let VMware make the decision for me, because otherwise things just get in a bit of a mess. Processors, I'm just going to go 2 and 2, but it depends on your machine, however many processors you've got. 2 and 2 will be fine. RAM, 2 gig would be absolutely fine. It'll work fine with 2 gig, but I don't want this class to run for any longer than it has to, so I'm going to go 4096 just so the installation runs a bit faster. Then we're going to leave it on network address translation for now, and leave all this stuff as default. Create a new disk. 20 gig will be fine. It won't be 20 gig, it'll be about 1 or 2. Store it as a single file just so it's easier to delete later on, and that's a fine name. I'm happy with that. Customize hardware. We don't need a sound card, okay? We don't need a printer, so we can just get rid of those. They're pointless. You don't have to do that, but there's no point in having a sound card on a web server. Hit finish. Now it makes a beep noise always when it starts the first. Every time, I don't know why, every time it starts the first time it makes that noise. So I'm going to go with a graphical installation, and I'll close off the library over here because we don't need the library, and we'll just... Right, so English would be useful. Notice that it supports a lot of languages. Some of them I can't pronounce. You could do it in Welsh. There's even, where is it? There's, let's have a look and see if it's still here. There used to be support for Klingon, but they seem to have removed it. No support for Klingon anymore. Esperanto is supported. You could do an install. Elvish. There's no Elvish, sadly. The problem with Elvish is you need to have an Elvish keyboard, and they're quite expensive. So that's the. If you install Linux with an Elvish keyboard, it's actually called Runix, because you need to have a Runish keyboard to use it. Quite difficult to, but you can go for what's this? C. No localization. That's a risky thing to do. Arabic, Asturian, Bosnian. So let's just go with standard English and then set the locale to the United Kingdom so that we have the @ symbol in the correct place on the keyboard, because that'll be annoying later on. And then the language we want to use is British English, not Brazilian. And then mount the keyboard. Now, what we don't want to do is we don't want to install anything that we don't really need on the server. Okay, we don't want to install anything that we don't necessarily want. So we'll only install the bare minimum, and also that'll make the installation run quicker as well. So here we have the IPv6 auto configuration, and it tells me that DHCP is succeeded. So hostname. Now this is the name that's going to appear before the prompt. So what I'm going to call this, okay, is I'm going to call this EC managing a web server, Moz. All right, EC minus MAWS. You don't want to try and put spaces in the host name or anything like that. Domain name doesn't matter. But if this was a real web server for a real website like myshop.com, we would put that in there. But we don't need to put a domain name in there. Right, root password. Now, what I'm going to do to make this easy is I'm going to make the password EC. Okay, just so I can type it in much faster, because I'm going to have to type it in a lot of times in this course. Okay, it's going to complain about the password. No, it's not going to complain. Going to put my name in there, and then what I'm going to do is I'm going to make my user password the exact same as well, just to make life even easier. So look, I'm going for EC for the password. You'd never ever get away with this on Windows. There's no way you would get away with this. Right, setting up the clock. Now the partitioning is really straightforward as well. We're just going to go for guided, use the entire disk. then we don't have to do it. We could go in and manually partition the disk, but I think life's too short. We've got a 20 gig virtual disk, and there it is there. It's coming up as 21.5. And all files in one partition. Let's go for that. And finish partitioning. Do you want to save? Yes, I do. Now notice there's two partitions. There's the ext4, which is the file system, and there's the swap, which is, in Windows this would be called a page file. So it's an area on the disk that if the memory fills up it can write to, and that's called the swap partition because it can swap data in and out of it. So Linux usually has a data partition and a swap partition. So let's write those to the disk, and then it'll do that quite quickly. Now the good thing about using this net install ISO is what happens is it doesn't have all the stuff we need in the ISO. Okay, what it's going to do is unpack a base system, and then we'll tell it what we want, and it'll download it from the internet. That way you don't have to have a 5 gig ISO. Now there is a possibility you can download a 5 gig DVD of the whole system if you want, but what's the point when we only want specific bits of the system? So we're better with the smaller net install ISO, and then we can add stuff onto it as we see fit. So the base system is just a small set of things just to get going, the basic Linux kernel and other drivers and stuff we need. And then what we're going to do once we have that is we're going to choose some options of what we want to add on. I had quite an amusing class once where they didn't add on the SSH server, and then they spent about 2 hours trying to get SSH to work. And then I said to them, do you actually have SSH installed? And they were like, I don't know. And they hadn't installed it. The partitioning method you want to go for is guided, use the full disk automatic partition. Okay, and it'll just do the whole thing for you. Right, so let's just go through this bit. Right, so now it's saying you've got the option of scanning additional media. Now, I had once an old tablet and I installed Debian on it, but it got stuck on the network driver installation because it was a funny driver. It was some kind of weird Broadcom chip or something. So what I had to do was get that driver and put it on a USB stick and put that into the USB port, and that's what this bit would be. We don't need to do this just now, but it's just if you're doing it on some kind of unusual hardware, you might have to go and get some drivers and add them there. So no, we don't want to add any additional media. The package manager. So this is just like, packages are downloaded using this advanced package tool, apt, or another package tool. Apt is stored on different servers around the world that are mirrors of each other. So when you say choose a mirror, we want to choose a mirror that's close by, so that we're not downloading the packages from, you know, somewhere really far away, because that's just going to slow things down. So choose United Kingdom, and then you can pretty much choose any of these. I usually just leave it on deb.debian.org, and then it finds the nearest one in the UK for me automatically. HTTP proxy doesn't matter. And then what's going to happen is, once it's configured the package manager, so now what we're doing is we're saying, when we type apt install, which server should we ask for files? And we're just saying we would like to ask the server in the United Kingdom. If you could, please. So next, what's going to happen is it's going to ask us to select and install software. Okay, so we'll just let this unpack various things. This might take a couple of minutes for it to get to the point. Unpacking Linux image 5.10.0.16. So this is the kernel, the Linux kernel. That's the version number of the kernel. Okay, 5.10.0.16. So I'll just see what I'm actually running on my local system here. Let's just go new tab. So to see what kernel you're running, you just do uname minus a. You have to spell name properly though. Uname minus a. Oh look, I'm using 5.10.0.16. What's this installing? 5.10.0.17. So we're getting a newer one on here. So this will install like the base system, and then we can decide what we need after that. Right. Do we want to join the popularity contest? No. You can if you want. Again, this doesn't matter. Popularity contest or no popularity contest. It's just basically they use this to figure out which packages should be added to CDs in the next distribution, which ones are popular, and if you join it, you send some statistics to them, and you can go to popcon.debian.org and look at the results of the popularity contest to see what are the most popular packages. I'm just going to say no to this because we're just using this for a test installation. Right, task cell is task selector. So this lets us select what we want. Now what we're going to do is we're going to add an SSH server, but there's no need to add a web server just now. So what I'll do is I'll grab a screenshot of that, fire that into the chat there. So that's the selection you want. GNOME and an SSH server, and then just hit continue. And that's it really. What it's going to do now is it's going to download 1,393 packages from the internet, and then it's going to install them. So while that's going on, what we'll do is I'll just pause this just now, and well, looks like it's downloading them very fast. The thing is, it's going to have to use that 4 gig of RAM that I gave it to install them, but let's just see how quickly it can do that. That's a very fast download, that, because of this new internet connection. Right, and then it's got all the files it needs. So now it's going to unpack all the files, open all the packages, and then install them. Okay, so unpacking and installing. Installing Python, installing Samba, installing anything that starts with lib is usually a library, like a software library. Codecs, Pulse Audio, some more stuff with Python. That's going fairly quickly actually. Unpacking the icon theme, so that's for the GNOME desktop display manager. Azrael is a card game. Unpacking more libraries. So wanted to show you quite an amusing video actually, so I wanted to do a little comparison between two. So I was showing the class the other day a video about Microsoft, a deep dive on Windows Server. Funny, this is a Debian conference where the guy's talking about integrating EM Debian, and he seems to be wearing a kilt, and he's got like a ponytail and stuff. I'll just let you hear a little bit of this guy's chat and kind of see the difference. Look at these people here. It's a completely different. I think it's a different target audiences. So.
Know what we've been doing. Yes, I know Nick does. So I've got the main picture up there, trying to give some idea of the divas of Debian that we have. The names are based on Squeeze, but we've kept the names.
So we skip it in a little bit. I'll show you kind of.
Charging systems again. That's a static unit. Minimal interactivity with the user, but it's just there to make sure it runs, it keeps on going, it logs things that are going on, it keeps in contact with its base station, and it just manages that one little pod in combination with another one. So you have got these fixed installations, minimal interactivity, full functionality, but the key point is that the software on that individual unit is binary compatible with what the developers are using back in-house to actually write the software and debug it and get all the problems out. You've got this match all the way down the stack.
Anyway, this talk actually kind of escalates, and he ends up in an argument with a German guy. But what he was talking about there is this thing called EM Debian, and it doesn't exist anymore. It's gone now. But it was embedded Debian, and basically, what did they use it for? Apparently, they used it inside electric car charging points in California. So it was like a tiny little embedded Debian that guy, he was the main developer of it, that guy that wears a kilt. And it was working inside these car charging points. So when you went up to plug your car in, a wee screen would say, you know, how much battery your car's got, and it would give you like a little readout and say how long it's going to take. Those were running on what was called EM Debian. Now this was about 10 years ago. I imagine they're running on something completely different now, but that's just a kind of illustration of the kind of things that people have done using the Debian as a base. If you think about trying to do like a mobile car charging point with Windows Server 2022, it just wouldn't be possible. You'd have to put, 16 gig of RAM in it and a SSD, and you'd have to do Windows updates, and there'd be security patches and things. So if you have a system that can be customized, there's definitely different applications that you can use it for. Right, okay, so let me just grab the Moodle page for this course, and we'll add on a new section called Web Server Concepts. So let's go Web Server Concepts. We'll keep this installing in the background. Turn editing off. Turn editing. Web Server Concepts. Add an activity or resource. Label. Okay. So, label text. What are we doing this week? Question mark. Talking about web concepts, then installing Debian 11.4 in VMware and setting up a web server. Okay, let's just make Debian with a capital D. Let's do save and return to course. And let's just do move that up to here. Right, so the final stage in the installation is, do you want to install the grub bootloader to your primary drive? The answer is yes, you do. I'll fire that one into the chat as well. Yes, you do want to install. Don't say no to that. If you say no to that, it's not going to work. And then it's going to ask you which drive do you want to install it on, and there's only one, dev SDA. So we'll install it to there. And then once it installs the grub bootloader, it'll reboot and we'll have a new system installed. So finishing the installation. Now, interestingly, the VMware tools that we install on Windows are called OpenVM tools on Linux, and in the past we had to install these manually, but now it's automatically detected that it's VMware and it's installed the OpenVM tool. So if I just hit continue, what's going to happen is we'll reboot, and we should have ourselves, here we go, brand new system. So let's just wait for this to load up. Loading initial RAM disk. Let's think about it. Now, what these little green OKs are is this is System D. System D has started, and then System D starts all the other processes. And I think I talked about this in a previous class, maybe computer operating systems or network security concepts. Right, so here we go. So if I click on that, put in my very secure password, we should have ourselves a brand new desktop. So let's wait. There we go. So we have it set up. We're ready to go with this now. Now, a couple of things I'm going to do just at the beginning. This is just purely cosmetic. You don't have to do this. Is get rid of some of this stuff from like the radio player and these things here. We don't need them. But what we do need to do is we need to put the terminal in our favourites, otherwise we'll have to keep typing in terminal. So we just right click on terminal, add it to favourites. Terminal is now, when you click activities, terminal is now in the favourites list. And what I'm going to do, just to make this easier for everyone to see, is I'm just going to change the size of the font So to do that, we just go to our unnamed profile here. We could give it a name, but we'll just use the unnamed. Tick custom font. Okay, and then I'm just going to make it a bit bigger. Okay, so I'll put it up to say 18 so everyone can see it. Okay, that's good enough. I don't want people to struggle to read it. Now, I prefer to use a dark theme on the terminal. Just find that a little bit easier to see. And if we just, let's go for solarized dark. Is fine. Might just make the text a little bit solarized. Oh, look. Yeah, I like that. We've got solarized, or we've got Tango. Say, pretty much the same, isn't it? Built-in schemes. There's solarized light. I prefer solarized dark. There's also the GNOME dark, which is not bad as well, but I'm going to go with solarized dark on there. So that's all we really need to do there. Close that down. Now, the first thing we're going to do when we have this is we're going to actually install a web server, and it's actually super easy to do. All we need to do is become root on the system. So to become root, you just type su minus, okay? You need to do the minus, and we'll talk about why that is later on, but just remember it's always su space minus or hyphen. Easier if I say minus. People sometimes don't know what hyphen is. So put in our very secure password, and then the prompt will change and it will tell us that we are now root, okay? And all we need to do to install the Apache server is just type apt install Apache 2. Okay, apt install Apache 2 is all we need to do. Now, if I run this, it's going to say, do you want to install it, yes or no? So what I can do is I can just add -y on the end, and that means that don't bother asking me yes or no. I'm going to say yes to that question. So we can apt install Apache 2, and yes, do install it. Don't bother asking me yes or no, just go ahead and do it. So if I then press return, okay, it's going to go and get the Apache server. And what that's doing here, creating a symlink, okay, a target, is it's setting it up so that it runs as a service on the system. So now I can type this command, systemctl status Apache 2, okay, and if it comes up with a green active running, that means it's working, okay. If it says dead, then that means it's not working, okay. Now, if we want to stop the Apache server, we just run systemctl stop Apache 2, and then if I run systemctl status Apache 2, you'll see that it says it's dead, inactive, dead since this time. So you press Q to quit. If you ever see this thing down here, that means it's a pager. So you press Q to quit out of it. So let's do systemctl start.
Yeah. Sorry, Michael, I'm just running through the installation now. Do we want to, on the software selection, select web server as well?
No.
Or install Debian?
If you look in the chat,
just SSH server.
Yeah, if you look in the chat, I've put a little screenshot of what you should select.
Ah, okay. Cool.
Because I thought someone would ask me that. I anticipated someone asking me that. So look, I'm going to do systemctl start. So I'll put these commands in into the chat just now. So apt install Apache 2 -y is the first command you want. Then systemctl, and then I'll create a set of options. You can have status, start, stop, okay, are some of the different options. Apache 2. Okay, systemctl. So in brackets, in the curly brackets there, those are the different options. So I'm going to start it, okay, and then I'm just going to check the status, and we can see that it's running again. Fantastic, right? It's running. Great. Okay. So how do we then look at the web server? Well, what we can do is open up our web browser and look at the local host address. Okay. Yes, all this very good. Thank you, Firefox, for all your startup stuff. So if I do 127, numlock's not on. That's 127.0.0.1 is the loopback address. We should see that we have the default Apache page running on the web server there. Now you might think, where is this page? Okay, where is this page stored? What this is down here is this is a layout of the configuration of Apache, and it tells us where things are stored. And down here it says, by default, Debian doesn't allow access to the web browser through any of the files in etc Apache. So the files are actually stored in var www. So I'll show you how that works just now. We cd to var dub, okay, and just do ls. We can see there's a folder called HTML, and if we just cd to HTML and do ls, we'll see there's a file called index.html, and if we have a look at that file, you'll actually see that that file is this file here. It's the default page. So that's where that's stored, var www html. Now that is sometimes called the www root. Okay, so the www root is the place where the web files are stored, the actual HTML files that are served by the server. The configuration files, though, are in etc Apache. So the next thing I'm going to do on this brand new server is I'm going to install Vim, because obviously if you try and use VI, the normal VI, you're going to have to know all of the shortcuts, and the arrow keys are not going to work. So it's going to get Vim installed as well while we're working on this. There we go. You want to get VI improved. Okay, you want to get the improved version of Vim. So now I'm just going to show you the main configuration file of the server. cd to etc Apache 2, and let's have a look in this folder. ls, right, ls minus l, so we get a nice list. So the main global configuration file of Apache 2 is apache2.conf. Okay, now on different systems it's sometimes called httpd.conf, but in Debian it's called apache2.conf. So if we have a look at apache2.conf, you'll see that inside here, this is a summary of how Apache 2 works in Debian, and we can set up, basically you could read this whole thing and it would tell you exactly how, like, do not add a slash at the end of the directory path, what's the keep alives, what's the keep alive timeout, hostname lookups, where are the log directories, what's the log level, where's the www root, where are the actual web pages stored. This is a bit about security, we'll look at that in a later week, htaccess. These are the log formats, we'll also look at that in a later week. And that's pretty much it. It's a pretty simple server, so I'll just come out of that file there and we'll minimize that. Now, what I'm going to do now is I'm going to create a super basic page, and don't worry, I'm going to give you a lab with these steps, so don't worry if you get lost while I'm doing this, if you think I'm going too fast. I'm going to give you these steps in a document. So I'm going to cd back to var, double dot again, var www, okay, I'm going to cd into the HTML directory, and what I'm going to do is just make a super quick simple web page. And actually, yeah, I'll show you how we can do this super fast. Alright, this is just a total basic web page, and maybe I should just make my font slightly bigger on this terminal, and actually I think I should change the color of the text so that it's not grey. So let's just do colors, text. I'm going to make it this like minty color so it's easier to see. I'm just going to make the background just slightly darker as well, so it's a better contrast. There, that should be easier to see. It's a bit more, a bit more of a contrast on the text there. So I'm going to just quickly put together a super quick web page and show you how you can host it. So we'll call this mypage.html, and then what I'm going to do is just go into insert mode, HTML, and then we'll close HTML. So every tag that gets opened needs to be closed. Okay, so we'll open the head and we will close the head. Okay, and we'll open the body and we will close. Now there are plugins you can have that would auto-complete this, but we're just going with total basic Vim here. Close body. Right, so we've got a head and a body for our page. Now inside the head we can put the title, so let's just fire the title in here. So let's do title, okay, and we'll call it my first hosted page, and then let's just close off the title tag, T-I-T-L-E, and then what we're going to do is inside the body we're going to put a heading. Okay, so let's just do here, we'll do H1, which is the biggest heading you can get, heading 1, top level heading, test page. Now I'm going to do a little bit of a hack here. Okay, this is old school HTML, this is not used anymore. You would do this with a style sheet, but just to show you what you can do, right, we'll do body bg color equals, and we'll give it a color of, let's just say red. I think that'll work. Right, so okay, so all I'm going to do is save this page. So now annoyingly I made that as root, and I wonder if that's going to cause us problems, but we'll troubleshoot that later. So mypage.html, so let's just copy that, minimize the terminal, and if we now go / mypage.html, we'll see there's the test page there being hosted on the web server. So I'll open the terminal to the side here and just move this, make this a bit smaller, and I'll show you two of them together. So vi my page. So there's the page that's in the www root, and there's the result displayed in the web server. Now we can change, we could put a hex code in here, like a nice kind of pastel green is am I in insert mode? CCFFCC. So we save that and then we go over here, refresh the page, you'll see it changes the background color there. Okay, and we can add other stuff, like let's do a heading 2. So H2, it's a smaller heading, H2. I made this page with VIM, and then let's just close off heading 2, save that, and then if we do refresh, I made this page with Vim. So a smaller heading there. So really, these web pages are just collections of files that are stored in the www root that will be served by Apache. Okay, right, that was quite an extensive demo there. So what I'm going to do is I'm going to show you, I have a lab for you to do this week that will kind of get you up to speed on this. So let me just open up this lab here, lab 1, and move this over, and I've accidentally opened it in the Brave browser, and we don't want to get that frame tearing again, so let's just open it in Firefox. Okay, so this task, alright, the purpose of this lab is just to familiarize you with, oh, it's telling me that I've got it open in another window, some of this content, okay? Now, really what I'd like you to do is just run through this in your own time and fill out the answers. There's a little bit of VI practice, there's some copying and pasting in VI which is super useful, and then this tells you how to go about doing what I just did there, make my web page, and then we're going to introduce this thing called Groff. Okay, and again this is just practice making a web page. So what you should be able to do with Groff is you're going to create, now this is a different markup language. This is a markup language that's actually called Groff. Okay, and what you can do with Groff is you can generate documents and host them on the server. Okay, so that's the task for this week, to learn how to generate a document with Groff and host it on your web server. So what I'm going to do is make this available to you just now. I will stop the recording. I believe we've been doing a fantastic recording with Voco Screen. Let's just, shall I stop it? Yeah, go on.